AP question. So the very first one says, let f of x equal x squared minus 9 over x minus 3 if x is not equal to 3, and 6 if x is equal to 3. So basically, we want to look at this piecewise function and think about how it factors and what our graph looks like. So when I factor it, the x minus 3's cancel, and I get x plus 3. So this is the line y equals x plus 3, but there's a hole. Where is that hole located? At what point? X equals 3. What would the y value of that point be? 6, right? Because if you plug in 3 here, you get 3 plus 3, which is 6. So this hole is at 3 comma 6. But the second part of this piecewise function fills in that hole. Did you guys see it? So when it says 6 if x equals 3, that fills in the hole for us. So we now just have the line y equals x plus 3. So the question, number 1, the limit does not exist. Does the limit exist or does it not? It exists. So the limit exists. So that's out. The limit does not exist is not true. All right, f is continuous at x equals 3. True? Yeah, because we filled in that hole. And then the line x equals 3 is a vertical asymptote? No. So our answer is 2 only.
Wait, what limit doesn't?
The limit does exist. So it's saying which of the following is true, and the statement said the limit does not exist. So be careful.
So how is the limit existing?
The limit goes to 6.
But it's filled in.
Yeah. So the limit still exists. Filled in points are the limits exist as well.
Okay.
All right, so number 2. So using the table of values of f of x below, the average rate of change of f on the interval negative 2 to 4 is what? So if we're on the interval negative 2 to 4, we're going to look at negative 2 and 4 for our x values. And the average rate of change is that f of b minus f of a formula all over b minus a. In other words, it's the slope. So we notice that we have 2 points. We have 4 comma 15 and we have negative 2 comma 1. So when we find the slope, we have 15 minus 1 over 4 minus a negative 2. So 14 over 6 reduces to 7 over 3. So it should be D. So every time you see average rate of change, you use the slope formula. What if it said instantaneous rate of change? Right, we don't have that with the table, but you could find it with your limit as h goes to 0, f of x plus h minus f of x all over h. That would be instantaneous rate of change. All right, the next one. Is this reminding you guys of some kind of theorem that we might have learned in class when we look at the next one? It is the Squeeze Theorem. So it says that h is sandwiched between f of x and g of x. And the limit as we go towards 2 for f of x is 5, and the limit as we go towards 2 for g of x is 6. So I don't know exactly how this is drawn. Something like, I don't know, it can look like that. But our other graph is sandwiched between them. So which of the following must be true? So f of 2 is equal to 5. Does that have to be true? It could be. If the limit goes to 5, it could be a filled-in point. But it doesn't have to be. It could be an open circle. We could have random points that are just filled in elsewhere. Does g of x have to be less than or equal to 6 for all x values? What do we think?
Yes.
It actually doesn't. Because we're just saying that the limit is 6. We didn't say, like, even how I drew it here, I drew it like up above, right? But our limit as we get closer to 2 is going to be that. We don't know like what the y values of the other points are. They're just getting closer and closer to 6 as we get closer and closer to 2. But we do know that the third thing is true because the limit as h goes or x goes to 2 of h of x, that is sandwiched between the other two limits. So 3 is correct. All right, so the IVT, intermediate value theorem. In order to use the intermediate value theorem, we need that f is continuous. Do we have that? We got it. And then usually we say like one of the f values is positive, one is negative, and that allows us to find a 0. This one's not like that, right? Both of our values are positive. So if we're talking about f of 2 is up at a height of 20, and f of 6 is at a height of 10, but we know we have a continuous function, we have to be able to connect those points in some way, right? And we don't know how they're connected. So here's a couple different scenarios. It could go up and then come down to that point, We could come down and then go up. We could do a whole bunch of stuff. Like, we don't know how we're connecting. But we do know by the intermediate value theorem that any number between here, we have to cross. Right? We're going to have to cross any number that's between there. So looking at these problems, it says, number 1, f of x is equal to 25 does not have a solution. We don't know necessarily that it doesn't have a solution. Do you guys remember the one that I just drew like this, where I said it could go up and then go back down? That could have a solution, right? We don't know what it does. So we don't know that it doesn't. It could not. So 1's out. F of x equals 17 has a solution. What do we think? That's true, right? That's a number that's between 10 and 20. That's when we would use the intermediate value theorem. So that yes, that works. F of x equals 0, could it happen? It could. Does it have to? No. So that's out as well. So it's 2 only.
We have not been with multiple answers.
I know. Don't you hate the ones where it's like, could this be true? This be true? 1, 2, 3, 1 and 2, 1 and 3.
They already in physics.
Those are hard.
And we all answered, and we all saw all of the above as the last one.
Yeah, there used to be a teacher who used to make multiple choice tests where you could have more than one multiple choice. So it could be like A, B, and D. Right? That would be terrible.
They did that Scantron.
Yikes. Yeah, that's how he's like Scantron.
They correspond, sort of like if they have more than say choice, they can correspond them to various. Yeah, oh my god, that was so.
All right. So next one. What's the max number of horizontal asymptotes you can have on a graph?
1.
Do we know? 1? 2. Grant is correct. It's 2. All right. The reason is because a horizontal asymptote, you think about the limit as x goes to both infinity and the limit as x goes to negative infinity. You have to consider both of those for a horizontal asymptote. Usually just one. Like the ones where they're just polynomials over polynomials, right? That's where you just look for the largest degree. It's usually just 1. But you could have 2. Do you guys remember the ones that definitely had 2? The absolute value ones, yeah. So like this next one. So we have the limit as x goes to negative infinity of 3x plus 2 all over the square root of x squared plus 4. So we approximate that by looking at our largest degree, which is x to the first. And on the bottom, when we do the square root of x squared, that's an x to the first term, but it's the absolute value of x, right? So if you plug in a really big negative number, so even if you think about like negative 100 like I did in class, you have negative 300 over positive 100. That will work out to be negative 3. All right, so you could always, like if this was on a calculator section, like that's when you can plug in like negative 500, negative 5,000, negative 5 million, right, and see what happens. Yeah, well.
So you said this one would have 2 horizontal asymptotes?
This one actually just has, well, the limit that we just found, there's only one thing there. But what if I found the limit as x goes to infinity as well?
That would be.
Then that's going to be positive 3, right? That is one that has 2 horizontal asymptotes. Do you see it? So the answer right now is just negative 3. But if I asked for the horizontal asymptotes of that function, there would be 2 of them. Because you want to do limit as you go to infinity and negative infinity. All right, this one's hard. So what a lot of people do is they just say that this is 0 because they think, oh, well, this is going to be approximated by absolute value of x minus x, like that. But this like approximation with absolute value of x is working for the quotients. It's a little bit trickier for this type of stuff. Okay, so this is a limit trick. And if you did have your calculator, you could, do the table of values. Do you guys remember doing that? And plug in 100, 1,000. Like you can plug in bigger and bigger and bigger until you do the really obnoxious just hitting 0 as many times as possible and see what it gives you. Sometimes it can't handle all of those. All right, but the way that you would solve this without a calculator is you would multiply by the conjugate. So we're going to multiply by the square root of x squared minus 4x plus x all over the square root of x squared minus 4x plus x. So on the top, we get x squared minus 4x minus x squared.
Close the parentheses.
You don't, does that bother you, OCD? Yeah. And then the bottom is the square root of x squared minus 4x, and then the plus x there. So on the top, x squared minus x squared, that goes away. And now you're going to do that thing where you're approximating. So we approximate all of this by looking at negative 4x over, What do I put on the bottom?
Y.
No. Just an x. Absolute value of x plus x. Why does this one have a plus x?
Because there's an X outside.
There's also an x to the first on the outside of that square root as well. So it's kind of tricky. So as you plug in a big positive number, see, this was x to the first as well. So the square root of x squared works out to be like an x to the first term, right? That's the largest degree, but you also had an x to the first on the end. Yeah, Ethan. What did I do?
Like what happens to like if x is
This was under square root, so they just multiplied, like they cleared.
no, sorry.
No,
Like,
on the
denominator. Like
Oh,
there's
the
x-
minus the 4x.
Yeah.
It's insignificant compared to the other one. Remember, like, you look for your largest degree. So that's like an x to the 1/2 degree, kind of. Like you would approximate it with that. So it's not as big. All right, so I get negative 4x over absolute value of x plus x. What do we think? Plug in a big number, like 100?
Negative infinity.
Nope.
Well,
Negative 400 over, if I plug in 100, 200, which is negative 2. Do you guys want to see this one with the table of values? Let's do that. So what if I go to my little calculator here? Do you guys know that Bugs Bunny is now called, the show is called Wabbit? Did you know that?
really?
Yeah, my kids watch it all the time, Wabbit. But that's what my calculator is called, Wabbit.
Wow.
Uh-huh. All right, so let's say we put this into the calculator and we do our table. And then you try bigger and bigger numbers. So let's, oh gosh, second table set. Make it so it's ask. So, I mean, you can plug in like 100, right? Negative 2.02, 1,000, right? And this is where you get obnoxious and do a whole bunch. And your calculator is getting closer and closer to negative 2. So if you're like, oh, I'm just going to keep hitting 0, sometimes that's when your calculator hates you. And it's like, no, stop doing this to me. It's not 0. That is not your answer. You have to be smarter than the calculator, okay? So, but you could do like several zeros, and it would still work out to negative 2. Okay? All right, and then the last multiple choice. So it says if the graph of f has a tangent line for all x, and we have 2 points, so f of 1.99 equals 4.988, and f of 2.01 equals 5.004, then which of the following is the best approximation to the tangent line when x is equal to 2? All right, so if I'm approximating the tangent line, I need a point and the slope. So if x is equal to 2, what do you think the y value is? 5. It's 5, yeah. We're going to use 5. And how do I find the slope? I have those 2 points, right? So I'm going to do 5.004 minus 4.988 divided by 2.01 minus 1.99. And I've already found that for you. It is 0.8. So if you're a good test taker, you would go through and you'd be like, oh, can't have that as a slope, can't have that, can't have that. It's between A and B. All right, and I can eliminate B right away. I know it's not B. Why do I know it's B, not B? Because it's 2, 5, not 0, 5, right? That's the y-intercept. It's saying the y-intercept's 5. So if you were finding it, y minus y1 equals m times x minus x1.
Cross out B for that.
You could cross out B because we know that it's not the point 0, 5. That's what that one would have. Right, so we don't have both the point 0.5 and 2.5 because then it wouldn't be a function, right?
So,
Why can't we have both?
oh, our point is 5. C.
Yeah, so if you were a good test taker, you can kind of get rid of a lot of things right away. Yep, so it's A. All right, and the last thing we have is a free response. It's not as hard as the actual free responses. Free responses can be difficult on the AP test. But by the end of the year, you're going to feel so confident going in, you're going to know this stuff. All right, so f of x. So this is a piecewise function. So the question for A says, are the lines x equals 5 and negative 5 vertical asymptotes of f? So it kind of looks like they are because of this, but one of them is not. Okay, so we're going to factor.
Negative 5.
You're speedy. So you factored into x minus 5 and x minus 2, and x minus 5 and x plus 5. And you can notice that the x minus 5's cancel. So that means that we have a hole at x equals 5. And we have a vertical asymptote
I miss you, Anya. It's too quiet.
at -5. Yeah, it is. Another good word for mathematical spelling bee. Weren't we talking about mathematical spelling bee yesterday? And Alicia with her,
Oh,
yeah, assess. All right. So B, identify all horizontal asymptotes of f, justify your answer. So the horizontal asymptotes come from the shortcut method. So you can use either the original or the simplified one. So if you look at x squared over x squared, or if you simplified it down to x minus 2 over x plus 5, we would still get 1 over 1. And that's fine if you do that on the AP test if you use the shortcut method. You don't have to do like the limit definition. Unless there's 2, then you should, right?
On such an case where it does like that, or if
Mhm.
you put, do you have to
Yeah.
put vertical asymptote, or if you put VA, would they count you off?
I don't know. You can probably put VA. All right, C. Is there a value of A that makes f continuous at x equals 5? Okay, so if we're going to plug in 5, I can't really plug in 5 to the top one, can I? So that's when you write your limit definition. So we say the limit as x goes to 5, x squared minus 7x plus 10, all over x squared minus 25. And we had already factored that. It was what, x plus 5 and x minus 2. Is that right?
X plus 2 over x plus 5.
I think it's simplified. X minus 2 over x plus 5, yeah.
Thank you, Steve.
So now are you able to plug in the 5? Yeah, you couldn't before, but now you can. So it's going to be 3 over 10. Okay, we wanted that all to equal A, right? This was our original equation. The reason we wanted it to be equal to A is because we were saying we were at the y value of A when x is equal to 5. All right, so how about the last one? So is there a value of B that makes f continuous at -5? No. Why? Not a horizontal asymptote. No. X equals -5 is a vertical asymptote. So there wouldn't be something that's going to make that continuous. Like you can't have something, even if they were both going up to infinity, I don't know what they're doing, but you can't like say, oh, I'm just going to put the point right there and then they're going to connect. Like it doesn't work that way, right? It doesn't work. All right, good?